Hello, everybody. All right, so we are starting our next unit. So this is actually two topics in one unit. It's going to be linear equations and it's going to be exponents and logarithms. So we are going to start with systems of equations and then move into the determinant. So this is everything that we're going to have to cover in this section. So there's a lot of things here. So as we go forward with this, just take note of what we're doing. Okay. So let's get started. We are going to start off with solutions. So when we deal with linear equations, especially systems of linear equations, you always have what's called solutions. So what happens is when you have a linear equation, there's two types of solutions that you'll come up with. You'll either come up with a consistent solution or you'll have one solution, which means it's a consistent system. So basically that means I cross in one spot. Or you have a no solution, which is called an inconsistent system. When we are looking at linear equations, we're looking at them in the form of ax plus by equals c. These two such equations are called a system of linear equations or a linear system. So system is two or more, basically. A solution to the system of linear equations in two variables. So we're just talking about two variables. It's going to be an ordered pair. And that ordered pair is specific because it satisfies both equations in that system. So when we are actually looking at systems and we're looking for the solution, what we're basically looking at is where did they cross? And when we look at where do they cross, we're going to be looking at a specific ordered pair. So consider the system 2x minus 3y is equal to -4 and 2x plus y is equal to 4. I need to determine if this is actually going to be a solution for that system. So basically what this is saying is that if this is a solution for this system, when I plug in 1, 2, so 1 for the x, 2 for the y, and evaluate, I should wind up with the numbers that are written over here off to the side. So all you're going to do is a plug and chug. You're going to plug this in and determine, does this actually work? So starting with the first one, we're going to go 2 times 1 minus 3 times 2. So 2 times 1 is 2, minus 3 times 2 is 6. So I get a -4. That one works. So then we try the next one. And we go 2 times 1 plus 2. 2 times 1 is 2 plus 2, that's 4. That one works. So yes, 1 comma 2 is the answer for this set of equations. So again, when they have a question that looks like this, you're just going to take the point that they give you, plug it into both equations, and you should get the answers that they're looking for over here. Let's try it again. So same thing, okay? So what's going to happen, so this is going to look a little different. So what's going to happen again is you're going to plug the answers in. So we get 2 times 7 minus 3 times 6. So 2 times 7 is 14, minus 3 times 6 is 18. That gives me -4. That one works. So then we have 2 times 7 plus 6. 2 times 7 is 14 plus 6, that's 20. That one does not work. So this one is going to wind up being a no. Because it doesn't satisfy both equations, 7, 6 is not a solution for this equation. It has to have both answers. Okay? So when you're looking for solutions, plug it in and see if you get the number that is set equal to on the other side, because you're just basically trying to stay balanced. So now, how do they actually get those actual answers? So there's these methods that you're going to use. Now, here's the deal. I'm going to show you this only because in your homework, it's going to say, what's the first step? What do you have to do here? What do you have to do there? Because it says that, I need to show you this. However, you're actually going to use the calculator to actually find your specific points. And I'm going to show you how to walk through that here momentarily. but you do need to know the steps on how to do the substitution method and the addition method. So that way, when your homework says, all right, so you have these two equations, what's the first step? You know what to do. So here we go. We're going to start off with solving a system by substitution. Now, this should be the key word. We're substituting something in. Basically, what that means is you're going to solve one of the equations for x or y, plug it in, okay? So the first thing, number one, solve either equations for one variable in terms of the other. So when you're looking at your equations, if you already have one, so I'm going to go back to show you. So if you have this system right here, oops. So if you have this system right here, and this was the one that says, okay, I want you to solve this for substitution, because you have that y by itself, you're going to want to solve this second equation for that y. Because what's going to wind up happening is then you're going to take this equation here and plug it in up here and factor everything down and solve for x. So that's essentially what we're doing. So we're going to solve either equations for one variable in terms of the other. Then whatever answer we get up here in number one, number two says substitute that expression that you found in step one into the other equation. Here is the key to that to make sure that you've done it right. This will result in an equation with one variable only. If you have two variables, you didn't do it right. You only should have one variable once you substitute in. And then you're going to solve. And then whatever answer you're going to get, you're going to take that answer and substitute that answer and solve for the other variable in the other equation. So let's take a look here. So I have 3x plus 2y is equal to 4. 2x plus y is equal to 1. So step one says take one of these. It doesn't matter which one, your choice. Take one of these and solve it for the single variable. So because this one right here is already by itself, I'm going to solve this specific equation. So I'm going to get y by itself by saying 1 minus 2x. And then I'm going to take this equation here, the 3x plus 2y equals 4. And I'm going to take, instead of the y here, I'm going to take this y and I'm going to substitute this in. So I've really got 3x plus 2, and then instead of y, it's 1 minus 2x is equal to 4. Because what I want to do is make sure I only have one variable. So I keep my 3x in the front. I'm going to distribute. And then I'm going to solve this now. So I get 2 minus x is equal to 4. I'm going to move the 2 over. I get negative x is equal to 2. So I get x is equal to negative 2. I now have the first part of my answer. So then what I'm going to do is I'm going to take this and I'm going to pick, it doesn't matter which one, I'm going to pick one of these. So because this one's already in the single variable here, I'm going to go ahead and take this bottom one here because it's going to be a little easier. And I'm going to say, okay. So now I've got 2x plus y is equal to 1. I know what my x is. So 2 times negative 2 plus y is equal to 1. So I get negative 4 plus y is equal to 1. So my y is equal to 5. And that is going to be the second part of my ordered pair. Therefore, that is my solution. If you need to check it, then you just take this, pick one of these, it doesn't matter which one, and make sure it equals one of those two answers. All right. Try it again. So, again, I'm going to take this one. I'm going to solve this for x. So I'm going to wind up with x is equal to 2y minus 3. Take that x, plug it in with the 5. So 5 times 2y minus 3 minus 4y is equal to 9. I have nothing but y's, which is absolutely what I want. I'm going to clean everything up. And then I'm going to solve for this y. So in my ordered pair, I know that 4 is one of my answers. I'm going to take that 4 and I'm going to use this one here because it's going to be easier. So x minus 2 times 4 is equal to negative 3. So x minus 8 is equal to negative 3. So x is equal to 5. So my other missing point is going to be 5. So that is the steps when it's asking for the substitution method. That is the steps that it's looking for. So if you're going through a problem in your homework and it says what's the missing step or whatever, you know how to actually approach it. So let's talk about addition method, because addition method is a little bit more difficult because there's a little bit more moving pieces here. So the end result's going to still be the same. You're still going to want to get one variable by itself so you can solve and everything else. And you're still looking for an ordered pair. The key is on the addition method is that you're going to want to cancel out one of the variables. So with the addition method, instead of solving for one of the variables, you want it into this format right here. And then, so this step number 2, this one may or may not be required because it just depends on how it's already set up. And that's going to be the key here is how is this already set up? And so what you're going to do is you're going to manipulate because you're going to pick a variable, either x or y, and then you're going to cancel out either x or y. It's going to be your choice on that one. So once you have both of your equations in this format, you need to figure out what do I need to multiply the top one and or the bottom one by so I can cancel out the variable of my choice. Once you do that manipulation in step 2, then you're just going to combine. It says add because it's called addition method, but combine the two equations together. So it's basically going to become a really big addition problem. And then the variable that you picked should cancel out, leaving you with the one variable that's left over. And then you solve, and then you substitute your answer. Here is the most important part to the original non-manipulated problem. Doesn't matter which one you choose, but the key is it has to be non-manipulated. So if you multiplied both of them, you need to go back to the original one and ignore the multiplication piece, okay? So let's take a look. So we're going to solve this by the addition method. So the nice thing about this one is it's already in the ax plus by equals c form. So I'm going to go ahead and I'm going to rewrite this over here. And this one right here. So now what I want to do is I need to pick one of the variables to get rid of. And it's like, okay, which one do I pick? Well, here's the key. So first thing you want to do is, can I go ahead and cancel? If I'm looking at here, if I combine the 4 and a 2x together, I get a 6. If I combine the 5 and a 3 together, I get a 2. So no, I can't cancel anything as it's written. So then I say, okay, can I multiply one of them by a specific number? So yeah, I can multiply this bottom one down here by a -2 so that my x's can cancel. That's fine, I can do that. Or if I take a look here at my y's, notice I have one positive, one negative. If I took my 3 and brought it up here and distributed, and my 5 and brought it down here and distributed, I can wind up getting rid of my y's. So it really depends on how you're going to approach this problem and what you're going to want to do. You want to do as little steps as possible. So I'm going to go ahead and get rid of my x's because I can take this whole entire thing here and multiply this by a -2. And when I do that, I get negative 4x my plus 6y is equal to negative 14. And then I have the original, which I did not manipulate at all. And then I have now what's called a really big addition problem. And if you notice, 4x and 4x go away. When I combine my y's together, I get 11y. And when I combine my 3 and the negative 14, I get a negative 11. So my y is equal to negative 1. So now I'm going to take that answer and either go back up here and just pick one to put it in, or only go back and put it into this one since I went ahead and manipulated that bottom one. It's going to be your choice. You can choose either one. So I'm just going to go ahead and take the top one because I know for sure I didn't mess with that one. So 4x minus 5 plus 5 times negative 1 is equal to 3. So 4x minus 5 is equal to 3. So then I have 4x is equal to 8, and x is equal to 2. So my solution for this one is going to be 2, negative 1. Okay? So again, how you approach the problem is going to be completely up to you. At the end, you and the guy you're sitting next to could, approach this 2 different ways, but y'all are going to wind up with the same exact solution. Okay? Let's try it again. Now, notice this one is not in that format. So the first thing we need to do is go ahead and get this into that format. So we've got 2x minus 7y is equal to negative 17. And then 3x plus 5y is equal to 17. All right. So now when I'm looking at this one, there's not a real easy way. But again, notice I have a plus and a minus here. So what I'm going to do is I'm going to multiply this top one by a 5. And then I'm going to multiply the bottom one by a 7. Because what happens is 5 times 7 will give me 35. 7 times 5 will give me 35. So I'm actually going to go ahead and just get rid of my y's. So when I do this, I wind up with 10x minus 35y is equal to, what is that, negative 85? And then 21x plus 35 is equal to, what, 119? Draw a really big line. Notice my y's cancel out. So this leaves me with a 31x is equal to, what is that? 85, 34? Did I multiply wrong? Or is this just going to be a really ugly problem? Nope, looks like I multiplied correctly. $21. All right. So x is equal to 34 over 31. All right. So then I take that answer and I can go back up here into the original. So 2 times 34 over 31 is equal to 7y minus 17. So this is 64 over 31 is equal to 7y minus 17. So I'm going to move that 17 over. So 64 over 31 plus 17 is equal to 7y. So we're going to open up our handy dandy calculator because, oh, look at that. It actually started this time. So let's go alpha y equals 64, 31 plus 17. So that gives me 591 over 31 is equal to 7y. And I'm going to take that answer and divide it by 7. So I get 591 over 217. 591 over 217. So my answer would be 34 over 31, comma, 591 over 217. All right. So now let's look at it in calculator form. So when you go through the steps, before we move to calculator form, when you go through the steps, pay attention to what you're doing and um, just keep everything, hold on, keep everything in an order. So that way, as you're looking at it and you're going through the process or whatever else, you can keep everything in a nice, neat order and go back in case you make a mistake or whatever. Okay. So I told you in the beginning that the majority of these you're going to do in the calculator. I needed to show you the steps because your homework will ask you, okay, well, what's the first step that you would do here? What are you going to multiply the top or the first equation or the second equation by to negate one of the variables? So if you don't have your handy dandy calculator out, go ahead and pull out your handy dandy calculator and let me actually walk you through this. Now, for those of you who have your own calculator, if you do not have this program into your calculator, if you have your transfer cable and somebody does, or if there's a way to get the calculator to me, I can load this up, but I'm pretty sure anybody who has this, the TI-84 that we use in the classroom, you should have that. And so this should be something that you're just going to be able to open up and load. So here's what you're going to do. On your calculator, you are going to look at your home screen and you're going to press the apps key on your calculator. So press the apps key on your calculator. And then you're going to see this whole entire list here. What you are looking for is going to be and it could be number 8 on some and 9 on the others, but you are looking for ply smelt 2. I have no idea what ply smelt 2 is, but that's just what they called it. So that's just what we're going to go with. So once you select number 9, then you'll get this menu. So because we're solving equations, what we're going to want is we're going to want number 2, simultaneously equation solver. So this is where you're going to enter in your systems here. And then you're going to get to this screen. Now this is probably the most important screen besides the next one where you actually plug stuff in. But this is where we're actually going to look at how many equations do I have and how many unknowns. So the equations is how many equations do you have, and your unknowns is how many different letters do you have, how many variables do you have. So right now we're dealing with a 2 by 2, and you're just going to leave everything else alone. And then you're going to hit the next button here. Okay. Now that next button should be right above your graph key. All right. So when it shows up, this next is right above your graph. So you're just going to hit your graph button, and it's going to take you to this screen here. And then you're just going to go ahead in the screen and you're just going to type in your equation as you see it. Now, for these front 2 up here, you actually have to hit the little negative sign if it is a negative number. And then it's going to go to the plus or minus here, and then it will go to the numbers in here. So the little negative number, if you have a negative number for your x's, and then it'll go to the plus or minus, and then you type in your number or whatever else. And then you'll just go all the way through. And then once you're done, you're going to hit the solve button, which again is your graph key. So once everything is typed in, you're going to hit the solve button, and then it's going to give you your answer. So this is what your solution will actually look at. And then you go to the next problem. And to do that, you go back to y equals, which is where its main's going to be. And it'll take you back to the first screen that we did. And you just keep doing it over and over and over again. So that is how you're going to use your calculator to actually help you find your answers. When we're dealing with systems, it's primarily going to be a little bit more calculator use than actually figuring out by hand. But you do need to understand and know the steps on how to do it by hand. That's why we went through all the other stuff first. Okay. So, so from here, we're going to look at a couple of different things in terms of systems, okay? So we are going to go to number of solutions. So when you're dealing with linear systems, you have different types of solutions. Sorry, I'm in class, so I'm sorry. That should be the last one until I'm done with the video. Yay! So when you're looking at solutions, when you're talking about a linear system, one of three things is going to happen. You're either going to have exactly one ordered pair solution, which means if it's one ordered pair solution, it's going to cross. You're going to have no solution, which means that they're parallel. Or you're going to have infinite amount of solutions, which means that it's the same line. There is no differentiation between it. Maybe just somebody took one of the lines and multiplied it by 2. Who knows? But the point still being is that they are the same exact line. And so they lay on top of each other. So these are the three types that you're going to get when you're dealing with one solution. Now, there are a couple of little tricks that you can look at. When you have no solution, that means you're going to have parallel lines, which means that your slopes are going to be the same. So if it's easier just to solve both of them for y to look at your slopes and determine if it's parallel or not, you can go ahead and do that. And the same thing, so when you solve that for y, you'll actually be able to determine if one of those two things are actually going to wind up happening. If one of those two things don't wind up happening because you're either going to get the same line on both of them or you're going to have the same slope with different y-intercept, then you know you're going to have exactly one solution. Okay? So now, solve the system of equation. What's nice about this is that your handy-dandy calculator actually will do this for you. So when you're actually going through this process, you're going to go back and you're going to plug this in. And what you're going to look for is on the answer slide, it's going to say one of a few things. So you can do this by hand if you wanted to, using the addition method or the substitution method, your choice, or you can go ahead and plug it in. And if you plug it into your calculator, you're going to wind up with a no solution found. That's because these are parallel. And just to show you, when you do this, if I just go ahead and solve the top one, so negative 2y is equal to negative 5x plus 4. So y is equal to 5 over 2x, was that minus 2? And then I solve the second one. 4y is equal to 10x plus 7. Y is equal to 10 over 4x plus 7 over 4. Notice that this 10 over 4x is the same thing as 5 over 2x. So if you notice that both of these have the same slope, and since they have the same slope, they are parallel, which means there's no solution, and your calculator will tell you that. Here's one with infinite amount of solutions. So again, I can put this in a y equals form. Since this one's already solved for x, I can just go ahead and say 5 times 4y minus 8 minus 20y is equal to negative 40. So I get 20y minus 40 minus 20y is equal to negative 40. My y's cancel out, and I have a negative 40 is equal to negative 40. That's a true statement. So since this is a true statement, you have an infinite amount of solutions. That means all your numbers are going to work. And again, your calculator is going to give you this. So this is how you know that it's infinite. This piece right there. Either the x's or the y's will have that right there. And so because of that, you know that this is going to be an infinite set. All right. So now let's talk about applications. So the main word problems that you're going to deal with in applications is going to be cost and revenue functions. So suppose a company produces and sells X units of product. Its revenue function is, ooh, I have a typo. I'm sorry about that. Is the money generated by selling X units of the product. Its cost function is the cost of producing X units of the product. So revenue is the money generated by selling. Cost is how much it's going to cost me to make. So revenue function equals your R of X is going to be considered your revenue function, and it's however much it is times X. So if I'm going to sell a Coke for, like $15 a bottle, my price would be 15 times X because I don't know how many I'm actually going to sell. And that's going to be my revenue. Doesn't mean I'm making a profit. It just means that's my revenue. That's how much money is coming in. My cost function is going to be how much money am I already out of pocket? Am I out of pocket, $137? Am I out of pocket $2,700? How much am I already out of pocket before I make anything? That's what's called a fixed cost. And then I'm going to add that to the cost per unit produced. So if it costs me $2,700 to set up, and then $1.50 to create each individual product, that's what this piece is here. This creating each individual product is my cost per unit X. So let's actually take a look at what this means. The point of intersection of the graph. So here's the other key thing. The point of intersection of the graphs of the revenue and the cost function is called the break-even point. So this is what we're looking for. So what's going to happen is you're going to graph the R of X and you're going to graph the C of X. And what you're going to look for is where do they cross at? And where they cross is their break-even. So that's going to be the minimum amount of items that you have to sell to get all your money back. And then anything above that is how much money you're actually going to wind up making. So the X coordinate of that point reveals the number of units. So your X coordinate will be, this is how many you have to sell. And the Y coordinates is the amount of money that you're going to have to make, or the money you're going to get back, one of the two. Okay. So that's what the break even point is going to look like. If we're talking about finding a profit, you take your revenue and subtract your cost from that, and that's going to be your revenue or your profit. Now, on this piece here, what you're looking for on the graph, so what's going to happen is this. You're going to have your revenue is going to do something like this. Your cost is going to do something like this. And then you're going to have your break-even point. And then what's going to happen is your profit is going to do something like this. So it's going to cross at where your break-even point actually exists at. And so this tells you where you're actually, or this is where you're going to start actually making money. And so anything up here, so anything above the x-axis is what we call in the black, which is good, which is what you want to be, because that means you're making money. And anything below the x-axis is called in the red, which is bad because you're still losing money. So once you hit this break-even point, this is when you start making money. And the profit function will actually tell you how much money you're actually making. And so you just have to pay attention. If they're asking about how much money you're going to be making after you sell 250 units, then you come and look at your profit function and you can take a look at that. Okay. So finding a break-even point. A company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoes. When they're sold at $80 per pair. I want to write a cost function and I want to write a revenue function. So let's start with the cost function. So the first thing I want to know in my cost function is how much money am I out of pocket before I even make anything. And for this problem, I am out of money $300,000 before I even start creating a pair of shoes. And you're like, that's a lot of money. Well, think about it. You got to have to buy your building. You're going to have to hire employees. You're going to have to get your lights turned on. You're going to have to get equipment. So you have to get all this stuff before you can start making it. And then it's going to cost you $30 to produce each pair of shoes. So on top of the $300,000 you've already spent, you have to spend another $30 per pair of shoes. Now you wonder why your Nikes and Jordans and everything are so expensive. The revenue is R of X. That is saying, all right, so we've done the cost, so they're sold at $80 per pair. All right, so cost function is this, revenue function is that. Determine your break-even point. Now, my cost function was 300,000. That's 30,000 plus 30x. My revenue function was $80 for the x. Okay. So when I'm talking about a break-even point, I'm talking about setting them equal to each other. So when I set them equal to each other, I have 80x is equal to 300,000 plus 30x. I'm going to move that 30 over and I'm wind up with a 50x is equal to 300,000. And then I'm going to divide by the 50. And when I divide by the 50, so when I divide this by 50 and that by 50, I get, what is that? 6,000. Yeah, I get 6,000. So what that is saying is I have 6,000 pairs of shoes that I have to make and or sell in order just to get my money back. So it's 6,000, and then I'm going to go ahead and just use the revenue one because it's a little easier. And so I'm going to say 80 times 6,000. It's going to be a 48 with 1, 2, 3, 4 zeros. And there you go. So this is my break-even point. I have to sell 6,000 shoes or get back to get back $480,000 just so I can start to make money. Okay. So that's going to be my break-even point for this, and this is what that means. I have to sell 6,000 shoes and create $480,000 before I'll start making any money. Determine when the company will start making a profit. So if you remember what I told you, your profit is your revenue minus your cost. And so that means my revenue is 80x, and then my cost is 300,000 minus 30x. I'm sorry, not minus, plus. So that winds up with 50x minus 300,000. But remember what I told you, that what I'm looking for is when this is going to wind up equaling 0. So I'm looking for basically my x-intercept. And when I told you this, that my profit is going to be at that same break-even point. So I know that I'm going to start making money when my x is equal to 6,000 pairs of shoes. So once I hit that 6,000, then I'm going to wind up making money. So anything above that is what I actually wind up which is what I wind up making. Okay. So that is what the profit piece looks like. So profit and your break even should wind up being the same answer. The only difference is the ordered pair, because at 6,000, my Y is going to be 0. And unlike on the other one, my 6,000 My y is at 480,000. Okay. All right. So now let's talk about 3 variable systems. This, guys, you are going to use the calculator on. There's no need to actually go through here and do all this by hand. The hardest piece is going to be setting up the equation if it's a word problem. Otherwise, if they give you the problem, then you're just going to go in and just put it into the solver and get your answer back. But in general, what a 3-system equation looks like is going to have 3 equations and 3 variables. Okay. So what that means is that in any equation, it's going to look like ax plus by plus cz is equal to d. So now we have this new thing right here, and that's going to be that third variable. And so your answer is actually going to look something like x comma y comma z, because you're going to have 3 answers on this one. The solution of the system is in 3 variables, which is that right there, and it's called an ordered triple. Instead of an ordered pair, it's called an ordered triple. And the solution set is the set of all of its solutions. So basically, it's just saying that this is going to be called a solution set. All right. So show that the ordered triple 1, -4, and 5 is a solution. Again, this is exactly what we did in the beginning. The only difference is now you have 3 variables versus 2. So you're going to take each one of these and plug it into each one of these and make sure that you wind up with answers that are sitting over here. So back this out. I'm going to take my first one here, and I'm going to say -1 minus 2 times -4 plus 3 times 5. It's -1 plus 8 plus 15. -1 plus 23, so that gives me a 22. So that first one is a yes. I have 2 times -1. And then minus 3 times -4 minus 5. So that's -2 plus 12 minus 5. So that's going to be 10 minus 5, which gives me a 5. So that one's a yes. And then we have 3 times -1 plus a -4 minus 5 times 5. So that's -3 minus 4 minus 25. -7 minus 25 is -32. So then, yes, that is the actual answer. Okay. So it's the same thing that we did at the beginning of all this. You just plug it in and make sure it equals the other side. And that all 3 have to equals. One of them winds up with a no, the answer is no. So in solving a system of 3 variables, again, you're going to go use your calculator for this. So you're going to walk through your calculator, you're going to put this in, and you're actually going to wind up with an answer. So I actually don't remember if this one has it. Nope, this one does not. So I'm going to show you a different way on this one. So I'm going to actually do this through matrix form. So what I'm going to do is I'm going to take this and I'm going to go second matrix, because you're actually about to use this here. And this is a 3 equation with 4 columns. And all I'm going to do is type in my answers here, or my coefficients. You should remember this from last year in Algebra 2. And 2, -3, 2, and -16. So this is just a different way of plugging it in if you don't want to use the apps. Like this calculator doesn't have the apps, so I'm actually going through matrix form. So for those of you who do not have it, this is how you're going to actually approach it. And what I want to do is I want to solve this now. So what I'm going to do is go second matrix. I'm going to come over to math. And what I'm looking for is RREF, this one right here. I'm going to go second matrix. I'm going to pick the one that I want to use, and always keep everything in fraction form unless they tell you otherwise. And then I'm going to hit enter. And so when I read this, notice my order, X, Y, and Z. So my X is equal to 1, my Y is equal to 4, and my Z is equal to -3. So let me just do this. Ooh, where'd it go? Oh, try it again. I'm going to do that. Copy. Come over here. I'm going to paste that in. Ooh, there it is. Look at that. So that way, when I write this down, I say X is equal to 1, Y is equal to 4, Z is equal to -3. So when I write my ordered triple, this would be my answer. Okay, so use your calculator. You can either go through that polysim or the polysmelt that we did earlier, or you can go through here in matrix form. Either way will work. So it's just whatever's going to be easier for you. Okay. If your calculator doesn't have that already loaded, this is how you will go about it in a different format. All right. So let's move on to our last topic here, which is the determinant. So again, this is a calculator based on this one. There's not much you really need to do. However, I am going to show you how to do it by hand first because there are some questions that are asked you, what's the first step? So we're going to start off the determinant of a 2 by 2 matrix. So in a 2 by 2, you're literally going to cross multiply and subtract. So when you're doing this, you only look at just the X and Y. We don't care about the answer. We only want to look at the X and Y. And so how we do this is going to be into this piece right here. So we are going to go from our first one. So we go this way first, subtract, and then this way second. And when you get this answer, that's going to be the value of this second order determinant. So that's what we're just looking for, this value. And what this does is later on, especially for those of you who are going to upper level math classes, this will actually help you solve equations a lot quicker. But for now, we're only just trying to find this determinant. We're not doing anything else but just trying to find the determinant. So evaluate the determinant of the following matrix. So when I do this, I want to start here first, and I'm going to go, let's make sure I don't want to write over anything. I'm going to go 10 times 5 minus 6 times 9. That gives me 50 minus 54, and that gives me a -4 as my answer. Okay, so when I'm actually evaluating the determinant, that's what I wind up needing to do. You multiply these two, subtract the multiplication of those two, and you're done. Okay. Same thing. So if I'm sitting here, I'm going to go 2 times -5 minus -3 times 4. So it gives me -10 minus -12. That winds up being a positive, so I wind up with a 2 as my answer. Okay. Now, 3 by 3 matrices are a little bit more difficult. So you're going to notice this really long formula here. You don't have to memorize this formula. There's actually an easier way for you to memorize this. So this is what you're going to do, is you're going to take your original matrix form and you're going to do this, okay? So you're just going to write down your numbers and you wind up with something that looks like this. And then what you're going to do is you're going to come over here and you're going to rewrite your columns just like that, okay? So you've got the original, and then you have column 1 and then column 2. Now what you're going to do is you're going to start off with all the positive ones. So when you do that, you're literally going to draw lines going in this direction here. And you're going to multiply, write your answer. Multiply, write your answer. Multiply, write your answer. And then you're going to do the same thing, but you're going to go backwards. And when you go backwards, you're going to go there in the red. You're going to multiply, write your answer, multiply, write your answer, multiply, write your answer. Then you're going to combine, and then subtract them. So let me show you what I mean. So we're going to evaluate this determinant using this matrix here. So the first thing I'm going to do is I'm going to go ahead and I'm going to write down, make sure I don't have that written here. I'm going to write this down. I'm going to go 2, oh, you know what, let me change colors here. Let's go black. I'm going to go 2, -5, -4, 1, 6, and 3, 7, 0, 1. Then I'm going to write my first 2 columns over again. So 2, -5, -4, 1, 6, 3. All right. So now what I'm going to do is I'm going to come over here and I'm going to draw my lines. So I'm going in this format this way. And then I'm going to draw my lines going this way. So just like that. Okay. And so now multiply 2 times 6 times 1. That gives me a 12. 1 times 0 times -4 gives me a 0. 7 times -5 times 3. So that's what? 35 times 3 is -105. And then I'm going to combine those answers together. So that gives me, what is that? It's 12 here. So that gives me 93 negative. And then I'm going to do the same thing coming up this way. I have -4 times 6 times 7. I'll go ahead and put my 0 there for that one, because we already know that that one's going to be 0. So then I've got, let's see what, -4 times 6 times 7. That gives me -168. And then 1 times -5 times 1 gives me -5. I'm going to combine these together, and I get -173. And then I take my -93, and then I'm going to subtract my -173 from that. So you're actually going to wind up subtracting these, because that's the order of the formula it wants you to actually do this in. So we have -93 minus a -173, and that winds up being a +80, and that's going to be your determinant. So again, rewrite your columns. From the top to the bottom is going to be your positive. From the bottom to the top is going to be your negative, and then you're going to subtract your 2 answers. Okay? So take a moment, try this one, because I know it's a little difficult, but go ahead and try this one. And go ahead and hit the pause button now. All right, so let's see how you did. So we have 4, -9, -3, 1, 3, 8, 0, 4, 1, 4, -9, -3, 1, 3, 8. So we're going to go in this direction. And then we're going to go in this direction. So this is going to be 12 and -12. Ooh, let's switch colors here. 12, -12, and 0. And then up here we have 0. And then, let's see, what is that? 128 and negative 9. So this will wind up being 119. This one down here winds up being 0. So we say 0 minus 119 gives me negative 119. And that will be your answer. Okay. So again, with this one, I recommend you actually using your calculator with, because it's going to be a lot easier. But if it asks you to show your steps or whatever, this is probably what it's going to ask you to do. It's going to ask you to actually do this formula right here. All right. And so when you're doing this formula, you just want to make sure that you have everything in order. All right. So again, your formula, if you can see the formula here, there's the A1, B2 that way, then C1, A2, B3, and then so on and so forth. So C1, A2, B3, and then there's that going backwards. So now let's use your calculator to do the rest of it. So the first thing you're going to do, you're going to press second, and this is x to the negative 1, so it's the inverse. That actually will be matrix. So second matrix, okay? Then you're going to arrow over to edit, and you're going to select number 1, or any one, actually. It could be any one of these that you want to actually do. And then you're going to enter your matrix size here. It's either going to be a 2 by 2 or a 3 by 3. So you just have to pay attention to what it is that you're going to be doing. Enter your matrix. So you're going to put your 2 by 2 or a 3 by 3, enter your matrix. And then when you're done, your screen, oh wait, I'm sorry, I went backwards. So when you put your matrix size in there, you're going to get this, and then you're going to enter your matrix. So it goes in this order here. It goes this one first, this one second, that one third. Once you're done, go back to your home screen by going second quit. And then you're going to go second matrix again, and then arrow over to math. When you get to math, what you are looking for is the very first one, the DET, that means determinant. So then you take this answer here, and then it's going to take you back to the screen, and then you're going to wind up with that. You're going to hit second matrix again. Select your matrix that you want to use, and then your answer is going to look like that. So once you go DET, go back to second matrix, plug in that answer, and then you're going to have a screen that looks like this. Hit enter, and it's going to give you your answer. Okay? So that's how you use the determinant in your calculator to be able to find it. All right. This takes care of those two ones that it's like 8.1, 8.2, and 9.5. So this whole lesson takes care of all three of those. So now that you have that, you can go in and start working on, I think there's only two homeworks. I think it's 8.1, and I think they put 8.2 and 9.5 together. So now you can start working on both of those homeworks on that, okay? Make sure you're sending me reminders if you have questions. Make sure you're sending me an email if you have questions or whatever else. Make sure you hit the Ask the Instructor button. We're coming up on Thanksgiving break, so I hope everybody has a wonderful break. Don't work too hard. Eat lots of turkey, and just relax and be merry and enjoy your family and friends, okay? Have a great Thanksgiving break, and I will talk to y'all, see y'all when we get back. All right. I will talk to everybody soon. TTFN. Ta-ta for now.